Hello, hello. Let me know when you can see and hear me. Hi. Hi, hi. Hello. Hi. Hi, Yashi. Hi, natural scientist. How are we? Hi, Chinwendu. I'm well, thank you, natural scientist. I'm excited for this titration that we're going to do today. How are you? Hi, young Cyan. Hello, hello. Okay, while we wait for a couple more people to join, um, maybe let's do a quick reminder of some promises that we have made when it comes to calculations, some processes that we should think about when it comes to these weird and wonderful and sometimes strange looking calculations. Um, what did we agree on? Lovely, nice to hear it, natural scientist. What did we agree on when it comes to calculations? What have we agreed? Okay, Yashi. So we might use Mr. Mole. It depends actually on the question. When in doubt, moles. Absolutely. What else did we agree on? Hi, Hassan. What else did we agree? What are we absolutely not allowed? Categorically banned. You're not allowed to attempt the Oh, yes, Shinventi, you must do something. Okay, no, oh gosh. You must not ever leave your calculation blank because you can always, at the very least, calculate. Again, I wish my head was small enough for this cap to actually fit. Okay, but you can always at the least calculate. Hi, Kimia. You can always calculate the moles of something. And then, oh no, what have I done to my hair? And then even if you can't get to the end of the calculation, you've still got something there. Okay, so are you ready? This is the last question from last week that we didn't get to, but it's such a good one. Okay, it is High Eminence. It is worth 7 marks. Okay, there's a lot of thinking that is going to have to take place for us to be able to really confidently approach this and get to the end, but we can do this. Okay, okay, Jess Pink, good luck with your intermolecular forces revision. Why 7? Oh, trust me, you'll see the 7 marks, young Sayan. You will see them. Okay. Oh, the hardest from the natural sciences. Sorry, I have a sneeze coming. Okay, no, it went back. That will depend on the individual, right? Some people will find biology the hardest because of the amount of content that you have to learn. Some will find chemistry the hardest because it's just so like abstract. Some will find physics the hardest because of all the maths and the all of that stuff. So it really depends on the individual. Personally, I found chemistry the easiest and I found physics the hardest, but that varies. There are some students that find physics the easiest and find biology the hardest, find biology the easiest. Like it really varies. Okay, hi Farouk. Hi, hi. Oh, again, natural scientist, it depends on the individual and how your brain works. So my favorite was inorganic chemistry once it got to, degree level, and I found physical chemistry the hardest. But again, people's brains like different things, and so different people will find different things difficult. Okay, for now, are we ready to get into the titration? I'm going to put it on the screen. Okay, let's take a deep breath together. It's okay. Okay, okay, let's read it. Hydrated aluminium sulfate is soluble in water. Aqueous aluminium hexaaqua aluminium ions react to form a stable complex when treated with an excess of EDTA4 minus ions. The excess of EDTA4 minus ions is determined by titration with zinc sulfate solution. So this is what they've done. They dissolved 1.036 grams of the aluminium sulfate in water and made up to 250 centimeters cubed. added 25 centimeters cubed of this solution to 50 centimeters cubed of a solution containing EDTA of that concentration, determined the excess EDTA by titrating with zinc sulfate solution in the presence of an indicator. The excess of EDTA ions required 18 centimeters cubed of this concentration of zinc sulfate solution to react completely. And these are the equations required. Yeah. But it's not redox. Okay, don't worry, young Cyan, we're going to go slowly. This is the only question that I've got for today. We are going to take our time with this one. Okay, now there's something or a couple of things that we can start to spot. Okay, we want to calculate X, which is calculating the water of crystallization. Okay, now whenever we are calculating the water of crystallization, we should think immediately, hopefully, how do we approach water of crystallization questions? If we want X, what do we actually need to calculate? What do we actually need to calculate to find out what X is? Anybody? What do we need? Could be Yashi. Absolutely, Hassan. Great, Chinwendu. We need to find out X. We need the MR of the entire salt, right? So our Al2, why did I do this so small? I don't know. Let me actually give myself enough space. I just know that I'm going to need a lot of space, so I'm trying not to take up too much. So we need the MR of the entire hydrated salt if we want to figure out how many waters there are. Okay, if we want the MR, how do we calculate MR? What would we need to calculate the MR? What would we need? MR is equal to lovely. We need mass and moles because MR is going to be mass. So the mass of the whole salt over the moles of, I could just write salt, of the whole salt. Okay. Now from this question, we've already been given the mass of the salt, right? We're told that we had 1.036 grams of the aluminium sulfate. We've got the mass of the salt, which means that we need to focus on calculating the moles of the salt. Actually, I'm going to write it all out. Okay, we need the moles of the salt. Okay, absolutely. It's not too bad. Hi, Alara. Okay, so again, we've got the mass tick, so we need the moles. How are we going to get the moles? This is where we really need to start doing some deep thinking, some critical thinking. So we can't, oh wait, yeah, where are the moles going to come from? Where are the moles going to come from? So this is where also we don't necessarily have a ratio yet. What we've been told from this question, and I'm going to draw some stuff out, right? So, forgive my terrible diagrams from the start. Actually, I'll do them up here. We have got our 1.36 grams of our aluminium salt. I'm just going to, of our salt. What do I want to write? Hang on a second. We have got our aluminium salt, XH2O, and we have dissolved that in a solution to make that up to 250 centimeters cubed. Okay. Then they have taken 25 centimeters cubed of that solution and added EDTA. Okay, at this point, it's worth considering what reaction is happening when we've done that. And that is clearly this first one here. Okay, the EDTA is reacting with the aluminium 3+ ions to produce our complex. Oh my gosh, what does it stand for? Oh my God, anyone in the chat that has it off the top of their head? I want to say, what is it? Ethylene di something, tetra something. Oh my goodness. It's a multidentate ligand that I can never remember the full name for. But it's got two, it's got, thank you, Eminence, ethylene diamine tetraacetic acid. That's exactly what I said. I'm joking. Thank you, Eminence. Great. So it's a ligand that can form a complex with the aluminium ions. Okay, so the EDTA in this step here is reacting with the aluminium 3+ ions. But they have added the EDTA in excess because they've now taken the EDTA that's left over so the unreacted EDTA, and reacted that with the zinc sulfate. So that's now our second reaction here. Okay. Is it starting to click, especially year 12s and year 13s, what type of titration we're doing? What type of titration is this? What type of titration? Can we spot? When we add something in excess, and then we take the excess and we react that to figure out how much reacted in the first place. What kind of titration is it? If there's anyone that's on TikTok that's answering this question, then make sure that you come over to YouTube. Link is in the bio, so you can tell me your answer. Anyone? When we add something in excess and then we take what's left over and then we react that, this is a back titration. Okay, this is a back titration. Okay, where we can figure out the moles. Hi, Liam. We can figure out the moles of the aluminium 3+ by seeing how many moles of the EDTA reacted with the aluminium 3+. And the only way to know how many moles reacted with the aluminium 3+ is to take the total number of moles of EDTA at the beginning and subtract the moles of EDTA left over. Okay, because the total minus the leftover, that will tell us the moles of the aluminium 3+. Well, that will tell us the number of moles of EDTA that reacted with the aluminium 3+. And as a result, the moles of the aluminium 3+. Okay, any questions so far? As I said, I'm going slowly through this. So if there are any questions at any stage, please stop, please ask. So Farouk, yes, this is an A level. So really, when it comes to A level, you've got your acid-base titrations, you've got your redox titrations, but then you've also got back titrations, which can be acid-base or redox or any type, where it follows these steps. Okay, we add a reagent in excess, and then we take what's left over and react it with something else, because then that's going to show us how much of that actually reacted. Hi, Hassan. Okay, actually, yeah, let's break this up into more steps. The total EDTA minus the leftover EDTA will tell us the EDTA that actually reacted. And once we've got the EDTA that reacted, from that, we can figure out the moles of aluminium 3+. And once we've got the moles of aluminium 3+, we can figure out the moles of the salt. Okay, that's a good question, Liam, from the question. Okay, so we can figure, they've told us where we're going to find these two values. So the total EDTA that they added at the beginning, that is up here. Okay, they've said they've added 25 centimeters cubed of this solution to, I'm going to highlight in a different color, to 50 centimeters cubed of your EDTA of this concentration. So that's the EDTA that was added right at the beginning. Absolutely. Okay. So why don't we start there? Why don't we start there? Okay. Okay, lovely, Hassan. Well, this is going to be your intro to A level. So, good luck. Okay. So we'll start with how many moles, total moles of EDTA. And that's what we added to begin with. So concentration times volume, 0.01 times 50 over 1,000, which gives us, what is that? Oh gosh, 5 times 10 to the minus 4. Lovely. So we've got this. Let's tick it off. Now, to find out the number of moles that were left over, let's again come back to the question, how did they figure out how many moles of EDTA were left over? Well, it says, determine the excess of EDTA 4 minus ions. Okay, how did you do that? By titrating. Hi, yeah, big up Naz Dubai. Hi, oh my gosh. By titrating with zinc sulfate solution in the presence of an indicator. Okay, so that's our second reaction here. The excess EDTA, which is our leftover EDTA, required 18 centimeters cubed of 0.0105 mole per dm cubed zinc sulfate solution to react completely. Okay, Brahampreet, for the moment, the drop-ins are A-level only, but there is, in the future, we'll hopefully do 2 drop-ins so that, GCSE are also getting some extra attention. Okay. So we can figure out the leftover EDTA by figuring out the number of moles of zinc 2 plus that it reacted with. Okay, so number of moles of our zinc 2 plus, which is the same as the number of moles of zinc sulfate. Lovely, thank you, Liam. So again, concentration times volume, 0.0105 times 18 over 1,000 to give 1.89 times 10 to the minus 4. Yep, fantastic, Liam. And it's a 1-to-1 ratio we can see in our equation number 2, which means that that is going to be equal to the number of moles of EDTA 4 minus remaining or leftover. I'll stick to leftover because that's the word that I used before. Do I know the answer? Yes, I do know the answer. Okay. So now we've got our total EDTA that we started with. Oh, not quite, Chinwendu. And we've got the EDTA that was left over, which means that the number of moles of EDTA 4 minus that actually reacted with the reacted with the aluminium 3 plus is 5 times 10 to the minus 4 minus 1.89 times 10 to the minus 4 to give us 3.11 times 10 to the minus 4. Lovely. Thank you very much, Alara, Yashi, and Liam. Great. So we've got the number of moles of EDTA that reacted with the aluminium 3 plus. So now from that, we can figure out the number of moles of aluminium 3 plus. From the ratio, we can see it's 1-to-1. So also 3.11 times 10 to the minus 4. That's the number of moles of aluminium 3 plus though in 25 centimeters cubed. Don't forget, we always want to look back to if we need a scaling factor. Did we take those moles out of a bigger pot? And yes, indeed we did. Okay, we figured out the number of moles of aluminium 3 plus here, but we need to figure out how many moles of aluminium 3 plus we had in our original sample. So how do we do that? How do we do that? Lovely, Liam. Times 10. So 3.11 times 10 to the minus 3. Great. Now we've got the moles of aluminium 3 plus. We need the moles of our salt. And I guarantee you, this is where I would say probably the majority of students would not get this mark. Okay, this is an A-star mark, this next mark, right? Because we would be really used to going, okay, great. The number of moles of aluminium 3 plus, that's the same as the number of moles of the salt. But that is not the case. Because if we look at the salt, what do we see? What do we notice about the salt versus the aluminium 3 plus? What can we spot? Yes, Liam, that part we absolutely can, but we're not quite there yet because we still need the moles of our salt. How do we do that? Looking at your formulae. How do we do that? If anyone on TikTok has the answer, come over to YouTube and feel free to share. Let me help you out a little bit. Let me help you out. Let's highlight. In our salt, I'm live on TikTok, but they're seeing this without being able to talk to me. Okay. If we look at our salt contains 2 aluminium ions, right? Let me make this hopefully even clearer. I'm going to come down here to the bottom. I'm going to switch my color so it's even clearer. Okay. When we had our salt, I'll ignore the waters for now because they're not going to be helpful in this part. When we dissolved this in water, this split up into the aluminium 3 plus ions and the sulfate ions, okay? For every one of these salts, how many aluminium 3 plus ions are we going to get? And how many sulfate ions? But the sulfate we don't care about. Lovely, Chinwendu. 2. Right? 2 aluminium ions and 3 sulfate ions. Now, the sulfate ions we don't really care about because we have currently got the number of moles of our aluminium 3 plus, and we need to use that to figure out the number of moles of our salt, so our Al2SO4 3.H2O, XH2O. So what's the ratio of aluminium 3 plus to the salt? What's the ratio? Lovely, Liam. Great. 2 to 1. 2 aluminium 3 pluses for every 1 salt. Great. Which means that our moles of the salt are going to be, it was really difficult to spot. 3.11 times 10 to the minus 3 divided by 2. That's why I said this is that A-star mark. And remember, you can still get, like 6 of the marks, for example, if you don't spot that. But that extra attention to detail, that's where, you see that difference. Okay. Wow, this feels like more than 7 marks. Like I'm tired. Let's take a deep breath. Oh, stretch. Okay. We've got the moles of the salt. Now what? So we're here. We've got the moles of the aluminium 3 plus, moles of the salt. So we're now ready to find the MR by doing mass over moles. Yeah, we're not done yet. We need to calculate X. We don't have X, right? The MR of the salt, the hydrated salt, is mass over moles. Our mass we already had from the question right from the beginning, 1.036 divided by the moles that we just calculated, 1.555 times 10 to the minus 3 to give us an MR of 666.2. Okay. So now I'm going to get rid of this little equation down here at the bottom. if we want X, you're absolutely right, Liam. We need to subtract the MR of the anhydrous salt. So our XH2O is going to be equal to the MR of the salt, the whole salt, the hydrated salt, minus the MR of just the anhydrous salt, so the one without the water. Okay, actually, let me write the whole thing so it's even clearer. Okay, which here is the MR of the whole thing. We found out 666.2. The MR for just the aluminium sulfate, thankfully they gave that to us in the question. So 342.3 to give us, oh no, 323. Hi, Anoop, 0.9. So to find X, oh gosh, we need a little bit more space. To find X, we are going to take 323.9 divided by 18, which is the MR of water. And that gives us 18. Well, 17.99, but am I behind my head? Just about. Yeah. Let's put it up here. Oh no, sorry. Come back. Wonderful. Yeah, wow is right, Yashi. Wow is right. Wow is right. The main thing, though, that I want you to take into account, okay? Let's say you you had no idea what to do here. Okay, let's say you didn't figure out all of the bits in the middle or the subtractions. What could you still have done? You still could have calculated the moles of the zinc sulfate as concentration times volume. Okay, you still could have calculated the original moles of EDTA as concentration times volume. And then you could have seen if you could do something with that, maybe a ratio, maybe a scale, and get a couple of marks at least. But there's no way that you can see a question like this and get 0 marks. Even if you've got no idea what you're doing, you cannot get 0 marks. You can calculate the moles and you can get something, even if that is absolutely it. Exactly, Chinwendu. And then you can always go to the rest of the paper when you're warmed up a bit. Actually, no, this is usually the last question, to be fair. These weird calculations, it's usually the last question. Okay, but you can always check your work, come back to it, or just go, hey, I've got my couple of moles marks, and that's good enough for me for today. That's valid. Okay, okay, well done. Any final questions before we go? Wow, a solid half an hour on this one question. Of course, it wouldn't actually, you wouldn't actually want to take half an hour, but of course we're explaining it slowly, which is why we've got that time. Yes, indeed, natural scientist, there is a computer science A level. Yes, indeed. Okay, but because not all 6 forms offer it, if you did want to study, let's say, computer science at university, computer science A level is not usually a requirement because they know that not everybody offers it. Okay, so usually what they're looking for is maths and further maths if you want to go and do computer science. Okay, yes, the shorts are still happening. There's a couple of GCSE YouTube videos happening. Also, don't forget GCSE students, and so year 11 students in particular, and year 13 students. If you have not already signed up for the Easter revision course, then you definitely should do that. Okay, the link is in the description for this video. So 2 days for GCSE, 3 days for A level over the Easter holidays, basically going through the entire course with some exam technique. Okay, so have a look. If you click the link, you can find out some more about them. Okay. Um, ooh, natural scientist, what does that mean? What does polymath mean? I'm not familiar with the term. Please tell me. Okay. Yes, indeed, number one. This is A-level chemistry. But again, this is one of the hardest A-level chemistry titration calculations that you would see. Okay, thinking about how much text there is, how small I needed to make this text just so it would fit on one page. You would actually have space to do the calculation. So don't let this one question put you off. But also, if it does completely put you off, then let it put you off. Okay. The chemistry AQA A-level Easter course, it'll be the entire course. So we'll do one day on paper one day on paper two, and one day on paper three. And then you'll also get like a bonus practice paper that you can do in your own time afterwards. Okay. Oh, Mustafa, again, titration calculations are usually across all A levels. So you could expect to see something like this, regardless of which examples you're following. I was studying all of the natural sciences. Oh, natural scientist, I mean, the name makes sense. Depends, I guess, on whether you would want to go more down the life sciences route or the physical sciences route. I think a safe one to have across the board is maths, right? Math, you will never go wrong by having a maths A level. If you can take a maths A level, as in like you are capable of completing a maths A level, then do it. Okay. And then pick your two favorite sciences outside of that. Okay. Hi, Daro. Hi, Maz. Hi, Sood. Okay. GCSE drop-ins again coming soon. Ooh, okay. Well, this question is from AQA. Yes, indeed. It will be intermix, so it's exam technique, but of course, to apply exam technique, there is some content that needs to be explained with it. So it's kind of exam style questions with kind of understanding the content that goes for those exam style questions. Okay. But again, if you go to the link, you'll find out more about how those days are structured and what is included. Woo woo, Yashi, indeed. Okay. Any final questions before we go? And before I go, eat my dinner. Okay, Laura. Yeah, I think, you know what, it's great to be a multidisciplinary natural scientist, but also don't forget, even if you choose just one science for your degree, that doesn't necessarily mean that you're narrowing yourself down to just that one science in the future. For example, somebody that was in my research group during the master's year for my degree, obviously, so they were doing a chemistry degree, but their focus was on computational and theoretical chemistry. So then they were kind of looking a lot more at that side of things. If you go down the organic route, sometimes that can lend itself nicer to biochemistry. So choosing one degree doesn't necessarily block you out, especially if that degree is chemistry, because central science, I mean, you can't really go wrong. Okay. What am I having for dinner? I am having chicken wings, and I'm so excited because they're my specialty. Okay. If anyone here that knows me in real life, I doubt it, but chef's kiss. Okay. Can one overdo the calculations in the question? What do you mean by overdoing calculations? Dara, so the year 12 summer course will include some like key concepts from GCSE that will be able to support you starting your A level. So it'll be kind of almost like a transition. So most likely some calculations practice, but towards the harder end of what you would see at GCSE so that you're ready for A level. Some organic chemistry, some bonding practice, so like the core, you know, transition sort of topics, equations, all of that sort of stuff. Okay. Okay. All right. Okay. Lovely. How do you revise for titration questions? I would say, Fazana, do, ooh, what would be my tip? Oh, where's my slide? Do I still have it? Close your eyes. This is, oh, there we go. This is my tip for titration questions. Okay. When in doubt, find the moles. Find the moles for whatever you can find the moles for. Then look at the balance symbol equation to figure out the ratio between what you found the moles for and what you're trying to find. that will give you the moles of your second thing. Sometimes there'll be a scaling factor if you took that sample out of a bigger sample. And then the last step depends on what they're asking you for. Whether you want the mass, the concentration, the volume, the MR, you just do that last bit of the calculation. So this is your process. Okay, when in doubt, moles. Okay, what do I think of psychology? I think psychology is a fantastic A level. It's great. It's very, very highly respected, very interesting. Highly recommend. Okay. Okay. Oh, hang on. Oh, so not for these subjects, natural scientists. At the moment for my ed space, it's just the core maths, English, and science. Okay, so maths and science, maths, and then biology, chemistry, physics for A level, and then maths, biology, chemistry, physics, and English for GCSE. Okay, there might be people out there online that focus on those top subjects, but not within my ed space at the moment. Okay. For Zana, it is not impossible if you put the work in, but also don't overwork your brain at the same time. How do you activate a mentor? If you haven't had contact from your mentor, then if you contact customer success, then and let them know, they'll be able to sort you out. Okay, but for now, I'm hungry. I'll see you next week. Okay. Bye, everyone. Bye. Really, really well done. See you soon. Thank you. Bye, 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 bye. No problem. Love to hear it. Okay, bye.